In Australia's vast outback, people report sounds that shouldn't be there. A low humming drone, sky-ripping booms, and dunes that seem to sing. From remote cattle stations to wind-scoured tracks, witnesses describe a pressure in the chest, windows that rattle, and tones that vanish the moment you try to find them. Locals have many names for it: the hum, the night drone, the sky trumpet. Explanations range from weather and geology to something stranger. On some nights, the air itself seems to carry it, a low, steady vibration that seeps through walls and skin, almost below hearing, entirely unforgettable. Out on the flats, dust devils twist and unspool. Rock shelves ring underfoot. Dunes whisper as grains slip. Nature's orchestra, tuned by wind and time. Then there are the sudden reports, a distant boom like far thunder on a clear night, startling stock, setting dogs barking, and leaving no trace at daybreak. Some swear the sound comes from the sky, others from the ground. Step toward it and it fades. Step back and it swells like a tide. Radio masts sing in crosswinds. Power lines moan. But even where there are none, the hum returns, soft, persistent, unclaimed. We'll follow the clues: dunes that sing, storms that boom, rocks that ring, and air that carries infrasound across impossible distances. We'll test ideas, wind shear, atmospheric ducts, microseisms from oceans far away, and see which patterns hold and which dissolve in the heat haze. Because out here, distance bends. Sound can crawl under the wind, skim inversion layers, and arrive like a ghost, loud, directionless, and late. In small towns, lights flicker. On stations, tin roofs tremble. People step outside into the dark, hold their breath, and the sound slips away. At first, only whispers and diary notes, then phone calls to meteorologists, geologists, radio techs, each with part of an answer, none the whole. The pattern repeats. Reports cluster near dry lakes, dune fields, and long flat reaches where the wind gathers speed and voice. Science begins at the edge of mystery. Measure, map, listen again. If there's a signal in the noise, we'll find its fingerprints. Until then, the outback keeps its counsel. Sand hissing, spinifex rustling, a low hum threading the night like a secret current. Dawn will come, and with it, new clues. For now, listen. The desert is speaking. Reports cluster around small towns and cattle stations: Coober Pedy, Tennant Creek, Birdsville. People hear a steady drone at night or sudden thunder with clear skies. Local radio hosts log calls, times, wind direction, barometer, anything that might connect the dots. Researchers bring microphones, infrasound recorders, and seismometers. They grid the desert like a crime scene for the ear. Patterns emerge: strong temperature inversions at night, long straight fetches of wind, and distant industrial sources carried hundreds of kilometers by the sky. But each time they close in, the sound slips away, masked by wind, swallowed by sand, or replaced by silence. They add arrays and triangulate, 3 microphones, miles apart, comparing arrival times to fix a bearing. On screens, rings radiate over maps, bearing lines, confidence cones, and shifting wind arrows. Logbooks fill with timestamps and pressure trends. Spectrum plots bloom with low, rolling bands. At dusk, they launch weather balloons, profiling the sky to catch the inversion that turns whispers into waves. Overnight, arrays listen, generators thrum, boots crunch, the desert breathes, and sometimes it groans. Seismographs catch distant rumbles that microphones miss. The earth itself becomes a witness. Each lead points farther out: refineries beyond the horizon, freight routes, power stations, possible culprits carried by the wind. Communities keep listening. Porch radios crackle. Calls come after midnight. Same hum, new wind. The story spreads: regional bulletins, national segments, yet the team keeps it clinical. Collect, compare, verify. By week's end, the map is a lattice of boxes and bearings, promising but inconclusive. Dawn to dusk, they close the gaps. And still, the Outback keeps something back. The line goes quiet. Summer heat, dry sand, a steep dune face. First suspect in strange desert voices, singing dunes, natural sand avalanches that can roar like a pipe organ. When grains are dry, rounded and uniform, sliding at roughly a 40-degree slope, millions of collisions sync up. The vibration amplifies a pure note that can carry for kilometers. Typical boom tones sit in the low voice range, often around 90 to 120 Hz, audible and chest-shaking when conditions align. Next, infrasound, pressure waves below human hearing. Microbaroms from distant oceans and long surf lines can drum continuously, traveling vast distances. At night, temperature inversions and atmospheric ducts can bend sound like fiber optic cable, guiding low frequencies over the horizon and making faraway sources seem nearby. Skyquakes, sudden booms can come from meteors fragmenting high in the atmosphere, thunderheads cracking aloft, or rare rock bursts as stressed stone releases energy. Geology matters. Dry lakebeds, mesas, and faulted crust can reflect and focus waves, turning a faint thump into a local boom. No explosion required. Human sources hide in plain sight. Mine ventilation fans, diesel generators, and long freight trains. Under inversions, their low notes bend, bloom, and travel. Add atmospheric ducting to industrial sites and you get convincing illusions. Booms and hums that seem to come from nowhere, then vanish with the weather. Space also plays a role. Fireballs and small re-entries create bright streaks. If you hear a boom minutes later, that delay often signals a high-altitude source. Evidence cuts myths down to size. Seismographs, infrasound arrays, weather radar, and lightning networks can timestamp and triangulate many of these events. Correlate the boom with fronts, tides, or rail timetables, and patterns emerge. Surf-generated microbaromes on stormy nights, trains under inversions, fans during maintenance windows. Not every case is solvable. Without sensors in place, fleeting sounds leave few clues. But physics narrows the field quickly. Most plausible culprits: singing dunes, infrasound from ocean microbaromes, atmospheric ducting, distant thunder or meteors, geological echoes, and industrial sources. One truth endures. Under the right conditions, the Outback becomes an acoustic lens, bending distant energy into sudden local sound. Keep it scientific. Measure first, myth last. For First Nations custodians, country is alive with story and sound. Respect the land. Listen before you speak. Science explains much: dunes that sing, air that bends sound, storms that boom, and machines whose rhythms ride the night. When the strange begins, note the wind and the weather, check local industry and power lines, and record carefully. Mystery shrinks with good data. Yet some nights, the Outback keeps a tune of its own, a low hum beyond the highway and heat, a reminder of distance, silence, and sky. Hold respect, share what you hear with rangers and elders. Because country speaks in many voices, we keep listening, we keep learning. Strange sounds or not, travel safe, tread lightly, and look up.